Hey Precalc. In this video, we're going to start section 7, 3, day 1, Hyperbolas. We're on our last conic section. After learning about parabolas and ellipses, I think this will be a pretty straightforward transition. So a hyperbola is the locus of all points in a plane such that the absolute value of the differences of the distances from two foci is constant. So kind of similar to an ellipse. We have focus points, we have a vertex, and then we have a center, which is actually going to be in between the two vertices. Okay, standard form is going to look very similar as well. If you have not printed this out, I would print it out to save you some time. So there are two different equations for standard form, and then we're going to follow the points, the key parts, I should say, depending on which equation you have. So similar to standard form of an ellipse, we are going to have x minus h squared over a squared. But instead of plus, it will be minus, which is kind of why instead of connecting, it's going the opposite way. And then we have y minus k squared over b squared equals 1. So it almost looks identical to the equation of an ellipse, but we have a subtraction sign. And then similar to an ellipse, our center point is going to be at h, k. So then for the other equations, very similar, except we will have y minus k squared over a squared. So if it's facing this direction, minus x minus h squared over b squared, and then, oops, equals 1. Getting ahead of myself. Equals 1. And then we have the center at h comma k again. And then just be careful because h is always going to be that x value, k with the y. All right, so then your vertices, if you are facing this direction, right, we're facing towards x values because our a squared is under the x. The vertices are going to be at h plus or minus a, and then the k value is going to stay the same. Whereas for this, when our y values are opening up, or we're opening up towards the y values because a squared, our bigger number, is over or under the y, our vertices will be at h, comma, k plus or minus a. Okay. Your foci for this version is going to be at, again, h plus or minus your c value, comma k. We'll talk about c in a moment. And for this one, it will be h, comma k plus or minus c. The transverse axis for this version is going to be y equals k. And here it's going to be x equals h. Okay, so it's kind of what part is going to be staying constant. So this connects the vertices. And the length will be 2 times a. So it's the distance that's connecting the vertices, and it will be 2 times the a value. Same thing for here. So that's the transverse axis. The conjugate axis, for this one, because it's y equals k here, it's going to be x equals h. And then for this one, because the transverse axis is x equals h, the conjugate axis will be y equals k. And the conjugate axis is perpendicular to the transverse. And has the length of 2 times b. All right, and then as you can see, these dashed lines, right? The dashed lines are going to be asymptotes. So you'll notice that it's getting close, but it's never actually going to intersect here because they're asymptotes. So for this first standard form equation, the asymptote equation will be y minus k equals plus or minus b over a times x minus h. So it's just in a linear equation where the slope is b over a. And then for this one, it will be y minus k equals plus or minus a over b times x minus h. And then finally, the ABC relationship. So we've actually done this before. C is going to equal the square root of a squared plus b squared. So similar, a little bit different. The C value is what helps us get our foci, just like it did with an ellipse. All right, so let's do an example. And then we'll call it good for tonight or whenever you're watching this. For me, it's night. Okay, so let's do one example. Given the equation, find the key characteristics and graph it. Okay, so let's do x minus 1 squared over 4 minus y minus 5 squared over 9 equals 1. So we know that this is a hyperbola, obviously, because we're talking about them, but more obviously because it's minus, not plus. So the first thing I recommend doing, I like to circle it, honestly, to be like, okay, which way is it going to be opening? I don't know why. So because this is going first, right? Because it's x minus 1 squared over 4, that means that we are going to be opening to the left and to the right, okay? So that being said, we know that a is going to equal 2, and b is going to equal 3. So I'm going to solve for c. So c is going to equal the square root. C is going to equal the square root of a squared plus b squared, so 4 plus 9. And that's going to be the square root of 13. Okay, so that's our c value. All right, so now let's go through our list. So the center is going to be at 1, 5, right? The vertices, so because we are opening up to the left and to the right, the vertices are going to be here and here. So from the center, we are going to go to the right 2, or a value. So that means that my vertice is going to be at negative 1, 5, and then my other vertice will be at 3, 5. So from our center, we go right 2 and left 2. The foci, right, because our foci is going to be inside the parabola parts, right? If we're going to, or hyperbola, I suppose. That means we're going to add to the x value of our center, so it's going to be 1 plus or minus the c value, which we determined is the square root of 13, 5. Okay, so that's the foci. And then we need to find the equation of our asymptotes. So the equation of our asymptote is going to be y minus 5, because of our center, equals, and then plus or minus, because there's two asymptotes, so we have positive slope and negative slope, and it's going to be b over a, so 3 over 2, and then x minus 1. And I don't think I really talked about how you get the slope, right? I talked about that sometimes, like in this case, it's b over a, in the other case, it's a over b. That has to do with y over x, right? Rise over run. So it's just like slope, I don't know, that you learn in Algebra 1. Okay, I'm going to skip transverse axis and conjugate axis for a moment, and let's just jump to the graph, and then I want to use the graph to kind of help go over those. So for my coordinate plane, I'm going to go up to 8 or 9. I'm going to do 9. 8, 7, 6, 5, 4, 3, 2, 1, 0. And then we don't really need much, so I'm just going to go to negative 1. And then on the x-axis, I'm going to go to, I don't know, 5, negative 5. Oh, no, it feels weird. Whatever. Okay, so here's my coordinate plane. All right, so our center is at 1, 5. Right? And then our vertices are going to be to the left 2, so negative 1, 5, and 3, 5. Right, so here's our center, here's a vertice, here's a vertice. The foci is going to be 1 plus the square root of 13. So, if you want to think about it logically, it's going to be 1 plus a little over 3, because the square root of 9 is 3, and the square root of 16 is 4, and the square root of 13 is in between. So 3 and some change. So over 1, 1, 2, 3, right? Oh, sorry, from the center. So 1, 2, 3. I don't know why this is. I'm struggling right now. Probably because it's night and I'm tired, and I taught all day. Okay, so then 1, 2, 3, and a little bit extra. Okay, before I make the shape of my hyperbola, at this point, we should graph our asymptotes. So basically, from the center, right, you're just going to use your slope. So we're going to go up 3, right 2, up 1, 2, 3, right 2, and then from the center down 3, 1, 2, 3, left 2. So there's one of the asymptotes. And then down 3, right, 1, 2, 3, right 2, and then up 3, 1, 2, 3, left 2. So here's the other asymptote. All right, and then once we have our asymptotes, it's a lot easier to make your hyperbola, because it's going to go through that vertex, and then it's going to kind of flatten out towards the asymptotes, right? Actually, that was very poor. Whatever. Okay, so there's my hyperbola. Now we're missing 2 parts. We do need to have the transverse axis. The transverse axis is going to be at y equals 5, and the conjugate axis is perpendicular, so it's at x equals 1. So transverse, I'm running out of time, y equals 5, and x equals 1 for conjugate. And that is it. Graphing hyperbolas.